going to be presenting, just a little about research methodology and biostatistics. Now, some key things that we want to go through is the, the definition of biostatistics. We are also going to cover, um, some key persons who would have aided in the development of biostatistics. We are going to look at research methodology um, broadly, and then we're going to focus a little on things such as the type of data. Yeah. Um, as well as we are going to talk a little also about um, you know some specificity as it regards to data, how we use data, how data can be represented, um, all in the effort to overall just get a better understanding of research and why we would actually carry out research for different purposes. And yeah, we're gonna end nicely by looking at the importance of research and biostatistics to society, because I understand for us to for it to really sink in, for it to really make some sense for us, it's best if we if we show the importance or value of it. Okay, so I have a presentation. Just allow me to share it with you. Let me just try to pull it up. Okay. All right. Almost there. Good. All right. So indicate if you are seeing my screen clearly.
Yes, I can see your screen.
All right. Awesome. All right. So let's start off like this. What is research and why is research important? Yeah. Um, so research, I'm gonna type research here in the chat, okay? Research. Okay, we're just gonna be a quick game. Okay. So research. Why is research important? Uh, I want you to just choose one letter from the word research and tell me something why research is valuable or important. Just based on that one word. Let me give you an example. So research is spelled Research. I could say reliable, because we do research if you want to get reliable information about a particular topic or problem. All right. So I just want you to choose any letter from the word research, and um, in that explain why research is important and valuable. Okay. So go ahead. I'll give you a minute to just type in the chat. Don't think about it too hard. Whatever comes to mind, just go ahead and type it. So I did R already. Someone just choose E, someone choose S, and then there's another E, an A, R, a C, and a H. Are you guys still hearing me? I'm wondering if I'm breaking up. Are we don't understand what is being asked? You can open your mic and say, yeah. Let me look in the chat. Romario, Melis, Abrahams, Chin. Okay, all right. Start to see stuff coming in now. H from Melis, helpful for figuring out uncertainty and concerns in daily life. Excellent. All right, very good. So research can be helpful. I agree. Anyone else? R, revolutionary. Okay, and what's the meaning behind that? What's the meaning behind that, Abrahams? And remember, for this session, it's a small group, so I'd say I'd give you total permission to open your mic and speak freely um, throughout. All right. Okay, so I'm not seeing anything else coming, so I'm going to continue with the presentation. I know it's customary to turn my camera on, so um, let me just turn it on. Uh, I know sometimes there's a bandwidth issue, so if I have my camera on too long, it might affect the quality of the presentation in terms of you hearing me clearly. So, um, so just turn it on to show you who you're talking to and who will be doing the presentation today. Let's go right into it. So, research methodology and biostatistics. Um, now, this is an overview of what we'll be covering. So, we're going to look at origin and development of biostatistics, definition. We're going to look at some reasons to know about it, why it's important. We're going to look at research methodology and types of data, graphical representation of data, frequency distribution of data as well. Now, what is biostatistics? Yeah. Any ideas before I go on? Any ideas? Then anybody want to um, indicate what they think biostatistics is? Simpson, Mellis,
The
Abraham.
most, the most I can think of is just like statistics that mostly revolve around biology or something
That
like
that
that.
is that is right on the money. Yeah. So biostatistics, yeah, has to do with um, in essence, looking at certain statistical areas, analysis, description, etc., surrounding biology or relating to biology. Overall, we can say statistics. Yeah, before we put the bio on it, because bio is a prefix that means life. Agree? Statistics is simply the science which deals with collection, classification, tabulation of numerical facts as Basis for explanation, description, and comparison. What this is saying is that statistics simply has to do with collecting information, classifying information or data, putting that together in a form or in a way that people are actually able to understand it, right? And we're gonna get into that shortly, because if someone gets some wonderful data, say you get some data about some computer codes, and it's all in ones and zeros, that's not valuable to anybody. It becomes valuable when you are able to put that in a kind of format that people understand. For example, you put it in a nice table, or you put it in a bar graph or a histogram or so on, so that it actually makes sense to persons. So a very important part of statistics is communication. You want to communicate some information or some data to persons so that they are able to receive it. So in terms of biostatistics, we can start looking at it from statistics in the broad medical research area. And it started in about 1929 when a huge paper on application of statistics was published um, by by Dunn. Now, by 1937, he started to see a trend in terms of the amount of articles that are being published in the form in form of books. So you had 15 articles by 1937 um, by Bradford Hill, and that's Austin Bradford Hill, um, that further pushed the area of statistics as it regards medical sciences and broadly biostatistics forward. By 1948, there were more persons publishing, and Bradford Hill actually became a key person of influence in the area. So if we think about persons of influence currently, as it regards to say, um, travel, but not, I would say interplanetary travel, say from Earth to Mars, we'd start to think about people like Elon Musk. We'd start to think about people like Jeff Bezos, because those are two persons who are pushing the limits of, you know, um, bringing people from Earth to outer space, on a commercial level. Yeah, another person is Richard Branson. So statistics just grew and grew from 1952 to about 1982, that 30-year period. It grew by about eightfold. So we had a great push in terms of statistics. These are some key persons. Yeah, you had some, Altman, Douglas Altman, Ronald Fisher, Carl Pearson, C.R. Rowe, and Gauss. These are some key persons who help to push statistics and biostatistics. Now, as we said before, and as Melly said, statistics that deals with biological things or the biological sciences, in essence, is biostatistics. Statistics arising out of biological sciences. Yeah. The methods used to deal with statistics in the field of medicine, biology, or public health for planning, conducting, and analyzing data which arise in investigation of these branches. Yeah. So in essence, bio meaning life relates to biology, public health, and general medicine. And then statistics, which is a collection, tabulation of information and data so that people can actually understand it. Is this making sense? Is this making sense so far?
Yep, I understand.
All right. So, uh, why is it important to know anything about biostatistics? There are several reasons. Medicine is becoming increasingly quantitative. This means that once upon a time, you'd go to, say, a doctor or so on, or a hospital, and they'd be acting based on what they think about something. Oh, we think this should be that way, or we think it should be another way. No, everything is getting increasingly quantitative, so numbers matter. In essence, people want data to guide the kind of decisions that they make. So if a hospital decide to create a new building that deals with cancer patients, for example, it would be based on quantitative information or quantitative data that they would have collected over time. So say they collected data that said people more people are getting cancer. Therefore, the hospital needs to expand their resources, both human and infrastructure, to accommodate the number of cancer patients that are coming in. It's quantitative, yeah. So also the planning, conduct, and interpretation of medical research are becoming reliant on certain statistical methodology. And what I mean is they are using certain statistical tools to analyze the data that they get. And we're gonna talk briefly about that shortly. Um, and statistics pervades the medical literature. It's very important in terms of the medical literature, and it's right throughout. If you take up a medical journal now, you'd see that you know statistics is very important, and they include statistics in it. So let's look at an example. Say you're doing an evaluation of penicillin, right? Treatment versus say penicillin and certain bacterial pneumonia in children. There are some key questions you can ask. First thing, we want to know what is the sample size needed to demonstrate the significance of one group against the other. Okay? If you're comparing persons, say, uh, you're comparing two groups of people, one that has penicillin and one that, deals with penicillin in terms of pneumonia in children, uh, under the year of two, you don't want to have what we call a representative sample. This means you can't have one group being 100 people and then the other group just being 10 people. That's not representative. We won't really be able to compare the results of 100 people versus 10 people. Okay. Another thing we don't want to look at is one treatment better than the other treatment? If so, how much? And then we'd probably even go on to ask why. Yeah. Let's look at another example. If someone has, say, let's use COVID 19. Yeah. Someone had COVID 19, right? And one person went, does that, by the way, let me ask, does anybody remember the vaccines that we used for COVID 19? Does anybody remember any other names of the vaccines that we used?
I can only remember Pfizer.
All right, so Pfizer was one. Another one was AstraZeneca. Another one was Johnson and Johnson. All right, so those are just three. And if one person took Johnson and Johnson versus Pfizer, we could ask a question: which one is more effective? And they actually did studies on this to find that um, Pfizer was more effective than AstraZeneca. So therefore, with this information, people might lean more towards using Visor because if it's more effective, then you want to use the more effective vaccine. So this is basically how you can use biostatistics. And if you were to compare a group of persons who used the AstraZeneca, um, yeah, versus the Visor, it wouldn't be fair. It wouldn't be a reliable way, or it wouldn't be representative if you had 1,000 people who took the Visor, and then you only had 10 people who took the AstraZeneca, and then you're trying to compare that results. That wouldn't make any sense. Therefore, it has to be representative. If you're using one sample, yeah, they have to make sense. So they have to align. So if you're using 1,000 people for AstraZeneca, it would make sense to use 1,000 people for Pfizer and vice versa. Okay? So you want to look at how reliable and valid the information or the sample is in order to get particular results that you need. Um, yeah. Now, in clinical medicine, documentation of medical history of disease is important. Yeah. Planning and conduct of clinical studies is important. Evaluating measures and procedures is important. When we talk about clinical procedures and clinical medicine, before, yeah, normally, let me say this, normally, before, say, a vaccine gets approved, it has to go through a series of steps. I mean, COVID was a little different in a way because of how quickly it came and the kind of impact it had. But generally, say you have a vaccine, there are certain steps you need to take before it becomes available to the public. So normally you probably hear that people are doing experiments on different animals, such as rats and rabbits. Yeah. This is normally a part of the clinical procedure. Yeah, where you test these animals first before you start testing it on human subjects. Good. And what you'd use is biostatistics. You'd simply analyze, how certain things are the medication or the vaccine affects these animals. Yeah? You'd collect information about it. And over time, you'd be able to make a decision or come to a conclusion of whether or not this works and if it works the way we actually want it to work, as well as any side effects attached to it. Good. Preventative medicine, on the other hand, has to do with magnitude of any health problem in the community. To basically find out basic factors underlying the ill health of persons, and to evaluate any health program introduced, and to promote the overall health legislation. So you want to put things in place. So, for example, currently, if we talk about preventive medicine, we have a massive campaign about exercising Jamaica Moves by the Ministry of Health, because they've realized that a lot of persons are having what you call non-communicable diseases, things such as diabetes, things such as hypertension, that it's basically the way you live. Yeah, it's a lifestyle disease. So they're trying to do preventative medicine to limit the amount of persons who have this. Yeah. Now, if we look at statistics generally, it covers several things. Yeah, it covers planning, because if we are going to do an experiment on rats, and say rabbits, we don't want to start planning and put certain key things in place, such as requesting ethical clearance to do it. Yeah, we try to get the resources we need and so on. Yeah. um we'd have to look at the design the design of the research. We'd have to look at execution of it, how the information is collected. We'd have to look at data processing in terms of how the data is processed, what you do with the data when you get it, analysis of the data, presentation of it, interpretation of it as well. Okay. And finally, very important, the publication of said data that you collect. Now, a biostatistician is someone who is able to help in each of those areas that I highlighted a while ago. Help in the design of the study, help in sample size, help in the selection sample, help in designing a questionnaire, help in the data management, as well as the descriptive statistics and certain other higher level statistics such as univariate and multivariate analysis. So a biostatistician would be able to help in terms of all the different steps um, of statistics and of research. Now, in terms of investigation, you'd want to first, you'd collect, and if you're in investigation and you've collected the data already, you don't want to ensure that the data is presented and starting from left to right. Good. You don't want to ensure that the data is described. You don't want to ensure that there is certain higher level analysis that's done if needed on the data. So data presentation would include tabulation, diagrams, graphs. Descriptive statistics would be, measure of say location, measure of the dispersion of the data, measure of what we can call skewness and kurtosis, how the data relates to, what's called a normal distribution curve. Um, so these are some ways in which once you've collected the data, the data could start to be analyzed. No, data. I've been talking a lot about data, um, but what are the different types? We can identify, for this purpose, three types: qualitative, yeah, quantitative. But we can break that down into qualitative data. Yeah, notice one is qual, and then one is quan, and then we have discrete quantitative and continuous quantitative. Okay, now qualitative data is what we call, we can say it's also a nominal data because it's dichotomous, yeah, or it can be dichotomous. It's discrete, specific. Um, an example of it is sex or gender, male or female. Yeah. We could look at, say, the exam results as well. So if you did an exam, it's either you pass the exam or you fail the exam. If we're looking at that level, yeah, in terms of nominal. Blood group, it's either you are A, you're B, you're O, or you're AB. It's discrete, it's very specific. The color of your eyes is another example. Whether it's blue, whether it's green, whether it's brown or black. All right. Can you think about any other nominal or discrete data? Something that's very specific. It's either this or that. Anyone? Anything comes to mind? Or not yet? Romario, Melis, Abrams, Chin. All right. Are you guys still hearing me clearly?
Yes, we can hear you. It's just I don't have any, like, I don't know anymore nominal data.
All right. Another one could be yes or no. If you ask someone a question, yeah, chances are you just want a yes or no. That's nominal. Yes or no. All right. So we also have what's called ordinal. So one is nominal, or it's very discrete. The next is ordinal. Um, and this with ordinal, you get a kind of range of answers. Yeah. So say you ask somebody about their response to a particular treatment that they're getting in hospital. They could say, wow, I think it's poor. Yeah. Or I think it's fair. Or you think it's good. So you notice that kind of range. Yeah. If I ask you guys, how are you doing? You could say, I'm doing great. Yeah. I'm doing very great. And that's at the other end. But you could say, I'm not doing great. Yeah. I'm doing very, yeah, I'm very sad. So you notice that kind of range that exists. So that's ordinal. Yeah. Another example for severity of disease, we could say it's mild, it's moderate, or severe. And for income status, we could say, persons are in a low, a middle, or a high income status. So that's ordinal. Um, mm, yeah. So let's look now at quantitative. So for quantitative, could be which is discrete. It could be the number of family members someone have, the number of heartbeats you have. Yeah, quantitative. If you count the number of heartbeats per minute, it's quantitative. If you look at the number of admissions, say a hospital have per day. So say you go to the Spanish Town Hospital or you know Kingston Public Hospital and you count how many people come in per day to visit the hospital. Yeah, that's quantitative. Um, but that's discrete. It's very specific at the same time. But you can have continuous quantitative as well in terms of height or weight or age because that changes. Agree? If you were to take your weight 6 years ago, chances are, you know, it's not the same weight you have now, and your height would have changed as well. So that's continuous, meaning it's changing over time. So if you and I know some persons do it. I don't know if you did. I did it when I was younger, where when you were really small, we had a like a pencil or so, and we just made a mark on the door jamb, yeah, to see how tall we were, and then every couple months, you just indicate or try to figure out how tall you've gotten. Um, yeah, that is continuous because it changes. All right. So in terms of discrete data, we can look at gaps between possible values, um, and theoretically continuous data. Um, there are no gaps between the possible values. Okay, let me go again. For discrete data, you could have gaps, right? For continuous data, you really don't have any gaps. So if for continuous data, you're looking at height, when you were two, yeah, you might have been, um, less than 1 foot. By the time you're five, you'd probably be say you know, um, or let's say, once you're 12, you're now probably um, 2 feet or so tall. But in between, when you were a couple months and when you're 12, right throughout, you've had a height. Yeah, you've never not had um, a height. So that's continuous because at each stage, every day you get up, you still have a height. Versus the discrete, data in terms of, the number of heartbeats you have per minute. That's very discrete. It's very specific. Yeah, for that moment. And if you go 10 years in the future, and take the number of heartbeats you have in a minute, it's very specific to that moment. Okay, so that's discrete. So you have certain gaps in between the values versus a continuous, you don't have any gaps. Okay, um, so continuous and discrete weight, you could be underweight, you could be normal weight, overweight, height, you could be short, medium, tall. What this is saying is that even for continuous data, we can break it down into discrete data. Good. So if you have the height of persons over time, which is continuous, it can happen over time, you can take that information and say, okay, at this point, this person was short. At this point, they were medium height. And at this point, they were tall. So you're able to break down, um, continuous data in discrete data. And this is why very often when you're collecting data, people tend to try to collect continuous data. Because when you collect continuous data, in essence, you can play around with it more. You can do more analysis with it because you can convert continuous data to discrete data, but you cannot convert discrete data to continuous data. Yeah. So if you have just some categories that this person is short, medium, and tall, that's as much as you'll have. You will not be able to take that short and say, okay, the short means that this person was 1.5 feet tall at this point, and this other person was 1.6. You don't have that information. Yeah, so you can convert from continuous data to discrete data, but you cannot convert from discrete data to continuous data. All right. Now let's just look at this table quickly. So this table has to do with number of persons in a hospital. Um, yeah. And based on the length of their stay. All right. Now, persons who stayed 1 to 3 days, we had 5,891 people who stayed 1 to 3 days. We had 3,489 people who stayed 4 to 7 days. Good. We had 2,449 persons who stayed 2 weeks. We had 813 persons who stayed for 3 weeks. And finally, at the bottom, let me jump here. We had 545 persons who stayed more than 1 month. Good. So this is collecting information um, and collecting data. And then we can break it down to say, okay, we know that 43.3% of people actually stayed 1 to 3 days versus 25.6% of persons who stayed 4 to 7 days. Only 3.1% of people stayed for 1 month. Yeah. So, we can collect this particular information and say you were a part of the hospital management. You could use this data, this kind of statistics, to guide decision making to say, okay, we actually need to expand the hospital now because we're having more people who are staying longer than before, especially if you compare this information with information that would have already collected, that you would have collected in the past. What I mean is, say for example, every single year for 10 years, you collected this information. Over time, you will have a trend to know, okay, there's actually more people staying longer or there's less people staying longer, and you'll be able to make adequate decision. So, so for scalar measurement, yeah, spoke about this qualitative, categorical variable. We have nominal, which is in essence a scale um, that classifies. So we can say it's classificatory. Um, for ordinal, which is ranking, well, that is something that's good or it's really bad. So these are what we call scales of measurement. All right. Now, scales of measurement can also be quantitative, which is a numerical variable. It could be discrete or continuous, as you mentioned. An interval scale, which is data placed in meaningful interval order. Okay, so for example, temperature would be interval. Um, and um, there's also what we call ratio, which, you know, has to do with things in a logical order. Now, you might say interval and ratio is very similar because, you know, both of them, let me go back to interval, both of them, it's placed in order and it's, you know, it's in a logical order. But for interval, notice that, you know, certain temperature, for example, 37 degrees, 36 degrees, and 38 degrees to 37 degrees Celsius are equal. Yeah. Um, but, and this is a very key thing to distinguish between whether something is an interval or a ratio scale of measure. We cannot say that 30 degrees Celsius is not twice as hot, um, or is twice as hot as 15 degrees Celsius. Whereas for ratio, if we're doing someone's age, we could say if someone is 15 and then another person is 30, the person that is 30 is twice the age of the person who is 15. For interval, you can't do that. Yeah. So the you know, the interval between, or the point between, or the gap between the two variables um, is not representative in a logical way for interval scale. Yeah, so that's something very important to note. So 30 degrees Celsius is not twice as hot as 15 degrees Celsius. Good. And, um, you know, negative 30 degrees Celsius is not twice as cold as negative 15 degrees Celsius. Okay. So that's a key thing to distinguish between ratio scale and interval scale. So examples of ratio scale could be your age, yeah, it could be your weight. Yeah, if someone is 100, if someone weighs 100 pounds, and then another person weighs 200 pounds, yeah, the person who weighs 200 pounds is twice the weight of the person who weighs 100 pounds. All right, so it's very logical. That's ratio. For interval, it's not that logical. All right, good. So the main ones to focus on is scales of measures, measurement, nominal, ordinal, interval, and ratio. All right. Now, this is what some of the data might look like in terms of when you're doing biostatistics. We might have different hospitals, yeah, um, persons in different hospitals when they were born, yeah, um, their sex. I'm looking at the top table, date of diagnosis, etc., etc. Good. So this is an example of some information that could be represented in terms of biostatistics. Good. This specifically has to do with table 2 has to do with persons with tuberculosis. Yeah. And this is a study done that looks at the outcome after the diagnosis of tuberculosis. Good. And it simply breaks it down in terms of the variable being the hospital sex, smear result, culture results, so on. And then it gives the categories there are and the type of variable. Okay, so let me ask a question. Sex. What what scale of measurement would sex be based on table 2.2 here? So we're just looking at scale of measurement. Which one would sex be? Anyone wants to take it? Any ideas? Which one would sex be? Would sex be nominal, ordinal, continuous, well, not continuous, interval, or ratio? Yeah, which one would sex be? Would it be nominal? Make a guess. Would it be nominal? Let me go back to this. Would it be nominal, ordinal, interval, or ratio? Who wants to go? It can be one of four, so you can just make. Is it nominal, ordinal, interval, or ratio? All right. Let's see. Nominal. Okay, so Shade says nominal. Anybody else wants to go? Come on, guys. Melis, Simpson, Abrahams, Chin. Let's give it a go. All right, nominal. So it seems like we're leaning towards nominal. I agree. Okay, so nominal. It's nominal because it's either or. It's very discrete. It's very specific. It's either you're male or female based on this study. All right. Um, good. All right. Um, okay. This is another study was done, but we're not gonna stay on this one. And this is another one in terms of just looking at the kind of data that would be collected as well. Yeah. Just give you a quick overview of what some of the data might look like. Okay. No. So we touched on this already. Once the data is collected, you want to represent it. Now, can we look at the importance to society, yeah, in terms of biostatistics? Um, it helps in terms of controlling epidemics and pandemics. Good. Um, it can create a population.
Mr. Scott, before you continue, what exactly is
Yeah.
your screen on now? Because it's not loading. I don't think. I'm not
Okay.
sure what you're presenting.
All right. So my screen is on importance to society. Okay. So we're not seeing the screen.
It's still on ordinal.
Oh, okay. All right. Let me stop sharing and then reshare. See if that works. Okay.
Yes, I'm seeing it now.
All right. Awesome. So the importance of biostatistics in terms of society is it can help to control epidemics and pandemics. It can create population-based intervention. Um, it can derive conclusion about population from sample, perform genetic studies, and entry points government program. So let's start with the first one. How how can understanding biostatistics control epidemics and pandemics? It can do so because once you're able to analyze things and look at the nominal data and the interval, well, based on the scale of measurement and the ordinal and the ratio, and you're able to analyze that by doing descriptive statistics um, and so on, you then can get an understanding of what's going on. And therefore, you'll be able to put measures in place. So when persons realize that the rate of contraction of COVID-19 was going out rapidly across the world, immediately you had these companies, they use that information, that statistics, biostatistics that they got, and they started to create vaccines rapidly so people could get it. So it helps to control epidemics and pandemics. And the difference between epidemics and pandemics, do we know? Do we know what constitutes an epidemic versus what constitutes a pandemic? All right. So a pandemic generally is something that it's worldwide. It's something that's affecting a very large amount of people across a very large geographical space. An epidemic is something that's affecting person within a smaller geographical space. So it could be, say, at a national level, you could have an epidemic. But if you have something affecting Jamaica, United States, Egypt, Japan, and several other countries, we tend to call that a pandemic. So the COVID-19 was a pandemic. Um, However, we've had dengue fever, for example, in Jamaica, and that would have been an epidemic because it's happening and affecting persons within a smaller geographical space. Okay. Now, it can also create population-based intervention. It can derive conclusion about population samples, and naturally, it can perform genetic studies about people using biostatistics. And it's a good entry point into certain government programs as well. Um, and what I mean is this: we spoke briefly about the Ministry of Health and what they are trying to do in terms of to reduce people who have reduce the number of people who get hypertension and diabetes and so on. Good. So you need statistics and biostatistics in order to know how many people and in order to put programs in place, because you can't just put a program in place because you feel that it needs to be there. It has to be based on something. And I want you to just quickly watch this video.
I'm not hearing the video.
Okay. All right. So no one is hearing the audio. Okay. Okay. Um, all right. Let me stop sharing this. And I'll just share the video in the chat. Just share the link. And you just take a minute. Well, the video is 3 minutes. So you can just watch the video. And then we'll just do a brief discussion of it. All right, so go ahead, watch the video, click on the link that's posted in the chat. Post it again. Okay. Um, yeah.